All right, so we're going to learn two important rules today, the product rule and the quotient rule. I think I mentioned this before, but a lot of times the algebra messes up people more than the calculus. So let's start off with the product rule. So if we're taking the derivative of two things that are multiplied together, we're going to take the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. So there it's written in two different ways. So let's use the product rule to find the derivative of f if we had x times x. So according to this rule, you're just memorizing two rules in this lesson. So if we take the derivative of x, the derivative of x is 1. And then, so the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. Now this is an example where we would not use the product rule, but I'm using it to illustrate the rule. So x plus x, that's going to be 2x. All right, so it says how could we answer this question in a different way? So x times x is x squared. And we learned a shortcut for the derivative, the power rule, and that was that you bring the exponent down and subtract 1 from the power. And so that's how we would have done that problem, obviously. But the purpose of this was to try to illustrate that this does work. Okay? So now let's try with some stuff where we do have to use it. We have no other choice. So we have the derivative of k. So that's going to be k prime. Now, you ought to be able to pause this and use the rule and not look up at the rule in your notes. So totally from memory, start memorizing the product rule. And hopefully we can do that here. So the derivative of the first thing, now this goes to, you're supposed to have a couple of these memorized. So the derivative of sine is cosine. So we're going to have the derivative of the first thing times the second thing. I would like to put those together right now, but I'm going to go ahead and write it out. Plus the first thing times the derivative of the second thing. The derivative of that's negative sine. All right? So if we clean that up a little bit, we're going to have cosine x squared minus sine squared x. Now, that goes to an identity that you may not remember. So as I look at this, I say, man, that kind of seems like it should be something. So if we go back to the cosine, we have a formula for the cosine of 2x. But we can derive that identity by splitting that up into the sum. And we talked about that in a previous note. So that would be the cosine of the first angle times the cosine of the second angle minus the opposite sine, and then the sine of the first angle and the sine of the second angle. So we can derive the double angle formula here, and that'll be cosine squared minus sine squared. And so now we see, I say, oh, that's that. So I can go backwards, and this would be the cosine of 2x. They're not going to have you do a ton of that on the AP test. They're not going to have you manipulate trig identities too much, but it is something that we ought to be able to do. Okay. So if we move over to this one, if we take the derivative of the first thing, that's going to be 2x, and then the second thing nothing happens to it. So the derivative of the first thing times the second thing. Plus, then we reverse it. So we take the first thing and we take the derivative of the second thing. The derivative, this is something you're supposed to have memorized. Again, pause between all these examples and try to do it yourself. So the derivative of cosine is negative sine. All right. So there's not a lot we can do here, but I can see that there's an x in both of those. So I could factor an x out. That would leave us with 2 cosine x minus x sine x. And that was f prime of x. This was k prime of x. Okay, so the product rule can be used with more than two things. And if you have more than two things, you follow that same pattern. So you're going to take the derivative of the first thing times everything else. Then you're going to move over and you're going to take the derivative of the next thing times the other stuff. And you're going to just keep moving over. So we're going to do one with 3 here. So there's going to be, so here's the first part. So I take the derivative of that, that's 1. Sine x times cosine x. Then I'm going to take the derivative of the second thing, so that's going to be plus. So the first thing stays the same. The derivative of sine is cosine. And we have that. And then the last thing, third thing here. So it's going to be plus x sine x. And then times the derivative of that, which we've said several times today already. It's going to be the opposite of sine. So what can we do here? Well, here, this is x. There's an x in both those, so I can factor that out. And then this is going to be cosine squared minus sine squared. Now, over here is probably something that we might not recognize, sine times cosine, but maybe you do. So we can derive that also. Again, probably not a big deal, but something that we ought to be able to handle. So I could rewrite that as a sum formula. I have the sum formula memorized. So for sine, it's the sine of the first thing times the cosine of the second thing. Now these things are equal, so we're getting the same angles there. And for sine, it's the same, so it's going to be plus. And so then it's the sine of the second angle times the cosine of the first angle, but since they're equal, and so that's 2 sine x cosine x. We have 2 of those. Okay, so if you compare that to this, what do we do here? Well, we have this over here. So to go here, we double the angle. But if we look at this, we take half of the coefficient. So double the angle, half the coefficient. So here, that's going to be 1/2 sine of 2x. Now, if you're like, Mr. Christensen, I got lost after that. That's not that big of a deal. As long as you could write that first line out, you're probably in pretty good shape here. Okay? So it's kind of the same thing up here. If you were okay, with that, that's pretty good. If you don't understand this last step over here, not that important. Okay. So this is cosine 2x. So our final answer So hopefully you have the product rule down, because now we're going to do the quotient rule. So the quotient rule looks a little bit intimidating maybe. If you take the derivative of 2 things divided by each other, and we have this. Now, the Swedish, people from Sweden, came up with this other way to remember that formula. And so it's over here. It's best done in a Swedish accent. My Swedish accent is probably not very good, but low d high minus high d low over low squared. So you don't have to say the Swedish accent, but this is how you want to memorize the quotient rule. So it's low d high. So low means whatever's in the denominator. Low, so that's v, low. D high is the derivative of what's higher, which is the numerator. So low d high minus high times d low, which is the derivative of the denominator, over low squared. High d low minus low d high over low squared. All right? Now, some students, so I put a note in here, some students try to change this to the product rule. And so they change this to u times v to the negative 1 power. Most of my students who do that get it wrong, because you still end up having to get a common denominator later. So I would strongly advise that you not use that way, because most people who used it got it wrong. Just memorize this. Low D high minus, so let's try it out. So low is x plus 1. Now, if you think you got it, try it out yourself. Pause the video and see what you can do. Low D high minus high D low. D low is just going to be 1. I'm going to put times 1 in my notes, but if I was doing this on my assignment or on a test, I probably wouldn't put times 1, because that's the identity. But it's for our notes to show that we did D high D low minus low D high minus high D low. So the derivative of the denominator is 1. Okay? So over low squared. Now, there are two terms in the numerator. I can divide out 9x to the 6th. That would leave me with 7. Give me 7 right here, which I could distribute to that. So that would be 7x plus 7. And here I would have minus x times 1. Leave that up. So now if I simplify that, it's going to be 9x to the 6th times 6x plus 7 over x plus 1 squared. All right? Now, as we look at this, so let's move that up, and we should be trying to do this without looking at the formula. We're trying to learn it. We're trying to memorize it right now. So if you, at first glance, you might say, well, why is I thought we were learning the quotient rule here. Well, oh yeah, we are. So why don't you think about that for a moment? And if we're using the quotient rule, we probably want to switch tangent to sine x over cosine x. Some of you, when you use trig functions, you don't write the angle. That's not good. You need to have the angle there. Just like some of you, when you write limits, you just write the limit and you don't write the function. That's not good either. All right, so now it's a quotient. Now we can use the quotient rule. Pause the video, try to write out the first step. See how you did. Low D high minus high D low over low squared. All right, so that's going to be cosine squared plus sine squared over cosine squared. Now, hopefully, some of you are like, hey, hold on a second, that numerator equals 1. Yeah. So that's going to be 1 over the cosine squared, and 1 over cosine squared is secant squared. So that's something we want to commit to memory. We already are supposed to memorize sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine. That should be on a list of things that you're memorizing. And you also want to memorize the derivative of tangent is secant squared. Eventually we'll have all 6 of those memorized, the trig functions. So memorize that as soon as possible. All right? Derivative of tangent is secant squared. Okay, now what happens is, now that we've hopefully learned the quotient rule, low D high minus high D low over low squared, low D high minus high D low over low squared. Every time some students see a quotient, they want to use the quotient rule, and we don't have to. So if we can avoid using the quotient rule, except that other way that I mentioned, we should do that. So here, when you look at this, so one of the things I write sometimes is if I see that I can rewrite something, I put a heart. I said that earlier in the notes. I love rewriting stuff because it makes it easier. It's the whole point. A lot of stuff in calculus can be rewritten. So instead of using the quotient rule here, what I would like to do is just simplify this. That's going to be 3 over 2. And then when I'm dividing something with the same base, I can subtract the exponents. So 5 halves minus 4 halves is x to the 1 half. And now I don't need the quotient rule. Now you could use the quotient rule and you should get the same thing, but it would be a lot more work. So now I'm going to use the power rule, which means bring this down and multiply. And we could show that if we need to, just because it's notes. So bring the 1 half down and then subtract 1 from the exponent. So that's going to be 3/4. And then actually, I'm going to drop that down here. We don't normally write stuff with negative exponents, except when we're doing work. Now, this one I've mentioned before. When you see a single term denominator, you want to use distributive division, or what I call sometimes the reverse common denominator. So what you want to do is split that up. Split that into 2 parts. So that's going to be 2x to the 4th over 5x squared minus 7x cubed over 5x squared. So you're just breaking that into part, putting this as the denominator of both of those. Because that's a common denominator, and you could, that's how we subtract fractions. So once we have a common denominator, then we apply that. Okay, so now if we reduce those though, we have 2/5 x squared and minus 7/5 x. Now that's much easier to deal with. So if we take the derivative of this, again, you hopefully pause that and did that yourself already. That's going to be, and then subtract 1 from the exponent, so that's going to be 4/5 x minus 7/5. Now we could clean that up a little bit and factor out a 1/5 out of both of those, and then we would just have 4x minus 7. But okay, so find the equation of the tangent line. As soon as you see that, you should be writing down a template for the answer. You have both coordinates here, so y minus y equals the slope times x minus x. So you should immediately have that much. Now the question is, what's the slope? Well, the slope is going to be the derivative, so we're going to take the derivative of this. So pause and apply your rule. Low d high minus high d low over low squared. All right, now we want the slope, so that's the slope, that's y prime. That's the formula to calculate the slope. Now, some students will immediately start simplifying this algebra in here. That's probably a mistake, because what I need to know is I need to know when x equals 2. So I could plug 2 in right now and probably could clean that up a little bit easier instead of doing the algebra. So 2 squared is 4 plus 3 is 7 times 1 minus negative 2. So that's a negative. So you would be careful. You're trying to do stuff in your head here. So that's going to be 4. This is going to be negative 2. Negative 2 is positive 2. So this is going to be positive 2 times 2 times 2. So that's going to be 8. So that's going to be plus 8. Or, let's see if I show it another way. So then down here, 2 squared is 4. 4 plus 3 is 7. 7 squared. I guess I could do it once. So that'd be 15 over 49. So that's going to be 15 over 49. That's the derivative. That's the derivative evaluated at 2. Okay. So, same thing again here. We were asked to find the equation of the tangent line. So I have y something equals the slope x minus 1. So that's our template right away because the directions say find the equation of the tangent line. Immediately go to that. Okay. Now this one is slightly different. That one they gave us the coordinates. This one they just gave us x. So what we want to do here is we want to evaluate, find out what y equals. So y, if we plug 1 in there, we get 1 plus 2 is 3, minus 4 is negative 1. So we're going to have negative 1 times and then if we plug 1 in here, we're going to get 3. So y is going to be negative 3. So the point is 1, negative 3. That's the ordered pair. When we plug this back into the original equation function, so we get negative 3. So y minus a negative 3 is y plus 3. So we had to calculate that first. Now we have to take the derivative. Okay? So if we take the derivative of this, that's going to be the derivative of the first thing, which is 2x minus 4, times the second thing, plus the first thing times the derivative of the second thing. So there's a lot going on there, but all I have to do is plug in 1. So 1, 2 times 1 is 2, 2 minus 4 is negative 2. 4 minus 1 is 3, and plus that's not working very well. Plus, and if we plug 1 in there, we're going to get 1, 3 minus, so we're going to get negative 1. And then times 4. So that's going to be negative 6 minus 4. So that's going to be negative 10 for our slope. All right. So it's kind of a joke a little bit, but we do this for a couple of different things. And so I've always told students, if you're not sure what to do on an AP Calc test or one of my tests after the limits, take the derivative and set it equal to 0. Because we do that for about 3 different things. So determine the points at which the graphs of the following functions have horizontal tangents. So they're talking about tangents. So that means that you should be finding a derivative. So tangent means find a derivative. So even if you're like, I'm not sure what to do here. Okay, find the derivative because you see the word tangent. So we are using the quotient rule here. So low, again, pause that video. Low d high minus high d low over low squared. All right, so what can I do here? Well, I could factor a 2x out of that first. That might be helpful. And then I would have x squared plus 1, and then I would have to distribute here. So I'd have minus x squared plus 3. Okay? And I just made a mistake. It's over low squared. So I started to square it, I put in parentheses, and then I lost track of that for some reason. All right, so now these x squareds cancel. Okay? So if we simplify that a little bit, we have 8x over x squared plus 1 squared. All right, So that's what you ought to be able to do because you see the word tangent and you've memorized the quotient rule. Now the directions say determine the points at which a graph has a horizontal tangent. Well, if it has a horizontal tangent, that means the slope is 0. So I'm going to take that derivative and set it equal to 0. Now, hopefully you know that, or if not, where I'm going to tell you right now, so it's fine. For a rational function to be equal to 0, the numerator has to be equal to 0 because we're not allowed to divide by 0, so that's not going to help us. So we need to know when this equals 0. Well, that's going to happen when x equals 0. If you divide both sides by 8, x equals 0. So it asked what point or points. Well, it happens when x equals 0. So if you plug 0 in there for x, you get -3. So that's the answer. All right. So let's try it again. Again, you should be able to pause the video and do it now. We just did it, but try to cover this up. So low, d high. Remember, I only put that times 1 in my notes, not necessarily in homework. So low d high minus high d low over low squared. Okay, and then we're going to need to simplify that up a little bit. So you want to be careful about trying to do too much of that in your head. You're going to make some silly mistakes probably. So minus 2x squared and then plus 2x. And that's still over x squared plus 3 squared. So if we simplify this, that's going to be -x squared plus 2x plus 3. Now, I'm just trying to set I'm not going to really worry about the denominator. I just need to know when the numerator equals 0. So I'm trying to set that equal to 0 just like we did over here. So I don't want to keep writing that down. I don't need it anymore. I don't really like that negative out in front, so I would flip the whole thing over. Like that. And then I'm going to factor. So that's going to be 1 and 3. Normally I would look at this sign first and realize that they're going to be opposite signs. It's negative there, so that's going to be a -3 and a +1. You should multiply this back real fast to check and make sure it equals that. So we've got a couple options here, either x equals -1 or x equals 3. So if x equals -1, we have that. And if x equals 3, we have this. So we put a -1 in there, we're going to get -2 over 4, which is -1/2. And if we plug a 3 in there, we're going to get 2 over 9 plus 3 is 12. So 2 over 12 is 1/6. So those are the points on this function where it has a horizontal tangent line. All right? And last question on these notes. This is on a lot of AP tests, and it's usually on a lot of tests in our class also. So it says, use the given information to find the derivative at 3. So instead of giving you something that you could use photomath on, they're giving you something that you have to maybe conceptually understand a little bit better. So let's look at what we have here. So we have 4. So we take the derivative of this. A number times a function, to take the derivative of that, that's just going to be, so we could say, so we're evaluating this at f prime of 3. We're taking the derivative and then plugging in 3. So we take the derivative of this, that's going to be 4g prime of 3. Taking the derivative of g, just multiplying that by a number, that doesn't matter. Same thing here, so the -1/2 will stay, and this is going to be h prime of 3. And now the derivative of 1 is 0. So I don't normally write plus 0, but since this is our notes, and our notes should be like instructions, I'm showing specifically that that equals 0. Okay, so g prime of 3 is -2. So that's going to be 4 times -2 minus 1/2. H prime of 3 is pi. So that's going to be negative 8 minus pi over 2, or you could leave it as minus 1/2 pi. But if I put it as pi over 2, that's one less character. It's more efficient. Being more efficient there. All right, so moving down to here, this is something we learned today. This is the product rule. We have two things being multiplied. So if we take the derivative of that, hopefully you can pause and write down what you should have. I guess I could have put a 3 in here, I suppose. Or we could put the 3 in after. I'll do it that way, I guess, this time. So the derivative of the first thing, so g prime of x times h of x, plus the first thing times the derivative of the second thing. If you feel more comfortable putting the 3's in now, that's fine. So g prime of 3 is negative 2. So I have negative 2. H of 3 is 3. So I have 3. Plus g of 3 is 4. And h prime of 3 is pi. So that's going to be negative 6 plus 4 pi. Write it out like this. That's your work. Show what this becomes, and then plug the numbers in. A lot of people miss these, and I can't think of a good reason why that should be happening, but it does. So, all right. So now we have the quotient rule. So the quotient rule, f prime of x, is going to be low d high minus high d low all over low squared, which would be 4 h of x squared. Okay, so getting these numbers from up here, we're going to have what? We're going to have 2 times 3 is 6 times negative 2, which is, that'd be negative 12. Now, if you have trouble keeping track of all those numbers, then write more of them down. We could write more of the substitution. So we have 2, and then we had h of x, so that's 3, and then we had g prime of x, that's negative 2. So we could be a little more careful there and write out more of the details. All right, so g of 3 is 4, 4 there, times 2 times h prime of x, which is pi. All right, so that's going to be minus 8 pi, and then 2 times h, so 2 times h squared, or h of 3 is 3 squared is 9, that's 36. So there's a couple different ways you could look at that. Now, all of these can be divided by 4. So divide by 4 over 4. Divide. So that's going to be negative 3 minus 2 pi over 9. All right. Now, I know I've mentioned this several times. When you have a single term denominator, split it up. So if you split that up, you're going to get g of x over g of x, which is 1, minus h of x over g of x. Okay, that's going to simplify this quite a bit. Now, if I take the derivative of that, f prime of x, the derivative of 1 is 0, minus, now I have a quotient rule, low d high minus high d low over low squared. Pay attention to the details. Notice how I one step at a time. I just wrote it down. Okay, and you could put the 3's in now, like so. You could put, well, if you put the 3's in here, you need to have a 3 over here. That's where you want to be careful about equal signs, where equal signs can mess you up. Because if I put f prime of x here and I put 3's in all those spots, that's not accurate. That's not good. All right, but let's finish this up. So we got to plug some stuff in here. So g of 3 is 4, and h prime is pi. So that's going to be 4 pi inside there. Then minus h of 3, that's 3. And then g prime of 3 is negative 2. And then down here, g of x is 4. So 4 squared is 16. All right. So all those can be divided by 2. So that's going to be negative 2 pi, because we're dividing that by 2. This is positive 6, but we have this negative out here that needs to be distributed. So that's going to be negative 6 divided by 2 is negative 3. And 18 divided by 2 is 8. All right. So there we go.